Hi, I'm Matt Reetz, Executive Director at Madison Audubon Society. We recently hosted Dr. Chad Wilsey, National Audubon Society scientist and co-author of the Birds and Climate Change report that was recently released. The report is really a wake-up call for all of us because it indicates that over half of North American bird species are threatened by global climate change, including a lot of beloved species that call Wisconsin home. During his visit, Dr. Wilsey joined me as a guest on the Larry Mueller Show, where we talked about the report. He toured our sanctuaries and he talked with Madison Audubon Society staff. And during his whole visit, he emphasized the importance of many things that we should be doing to ensure a brighter future for our birds. These are things Madison Audubon Society is already doing. One of these is education. We are sharing the report with our members and with the broader community. Our growing education program is reaching out to new communities and talking about the importance of bird habitat and bird conservation in general. And we are fostering a love of nature in the next generation of Wisconsinites. The second thing is that we really have to protect the places where birds are now. Madison Audubon Society is no stranger to habitat protection. We have 1,400 acres of protected lands, much of which has been restored to native prairies, wetlands, and all sorts of habitats where our birds are really flourishing. It's going to be very important for us to continue to protect those places. They will be very important for birds, not only now, but in the future. So I hope you enjoy Dr. Wilsey's talk, and I encourage you to go online and check out more about the National Audubon's Climate Change Report and find out what you can do to help. And I also encourage you to join us here locally, as we all here at Madison Audubon Society work together towards a brighter future for our community, our children, and our birds. Thank you.
Thanks, Mike. Well, Matt, well, it's always a real treat to be able to introduce a former student, especially when they've gone on to do good things and are coming back to campus to share an important story. So it's a particular pleasure to be able to introduce Dr. Chad Wilsey tonight. Chad did his master's degree with me here in the Nelson Institute. So Chad's background, he has an undergraduate degree from the University of Puget Sound. He worked for a few years after that teaching in Mexico and Costa Rica, and then came to the Nelson Institute, where he spent 2 years as my student, doing something that most students who are interested in nature would probably have preferred not to do, and that was working in an agricultural system rather than in a wilderness area. But he did a really great job studying agroforestry practices in cacao and banana plantations in Costa Rica. And I assume you all drink bird-friendly coffee and maybe biodiversity-friendly chocolate, so you know the importance of those types of agroforestry systems. After leaving Wisconsin, he again spent a few years practicing conservation before going back to get a PhD at the University of Washington in landscape ecology. After graduating, he did a postdoc looking very specifically at some of the ways that we might be able to predict the responses of endangered species to various environmental changes that are coming at us rapidly. And then last December, just a year ago, took a job as a conservation scientist in a new program at National Audubon Society as a spatial ecologist. So this has obviously been a very important year for reports on climate change. We've had the Intergovernmental Panel on Climate Change release its 5th report, global report. Here in the U.S., we had our National Climate Assessment released by the federal government. In Wisconsin, the Wisconsin Academy of Science, Arts, and Letters reduced its Climate Forward report. And of course, for those of us interested in birds, 2014, the State of the Birds report was done. And Audubon's Birds and Climate Change report came out. Chad's work is obviously directly related to that work of Audubon. He's going to tell us about it tonight. Chad.
Everyone hear me? Not so much. If I talk How does that for sound? A little better? Okay, we'll work with this. Yeah, we want to make sure that everyone can hear. So how am I doing now? Does that sound good? That's better? Great. Thank you very much, Stan, and thank you, Matt. I'm really excited to be here tonight. Thank you, everyone, for coming out. You've kind of heard my story. I guess the only piece I wanted to add to it was that I'm from Milwaukee. I grew up in Wisconsin. This is a picture of me and my dad out on Lake Michigan. It's really special for me to come back to Wisconsin and share this research that I've been working on with you. I am someone who got into birds late in life. As Stan mentioned, I started off as a teacher. I was teaching down in Costa Rica, and just, as you can imagine, I was a biology teacher and just became fascinated with all of the bird species that I could see down there. The first time I saw my chestnut-sided warbler was down in Costa Rica. Saw many of the species that I then later learned about when I came and did a master's at the University of Wisconsin. I had first seen them when they were wintering in Costa Rica, and then finally got the opportunity to see them up here during their breeding season. And so, yeah, I took my first ornithology class with Tim Mormon here at the University of Wisconsin, and I've really tried to work with birds as much as I can ever since then, and feel very fortunate to now be part of the conservation science team at the National Audubon Society. So, just kind of want to start off with that little personal introduction before digging into this. So I wanted to start off just quickly talking about the difference between weather and climate. When we were scheduling this meeting, I was thinking, okay, Wisconsin in the fall, it's going to be a little chilly. But certainly I didn't imagine that we were going to have the forecast that I was looking at on my computer screen last week when I was putting together this talk. It's unseasonably cold right now, and here's somebody on Twitter putting their post saying, snow in northern Wisconsin on the 11th of November. That's not a normal year, and it's important to remember that climate change doesn't necessarily always signify warming. It also can mean just a change in our general climate patterns and an increase in the frequency of extreme events. One of the what's happening right now is actually called an omega block, and basically what's happening that's bringing us this cold weather right now is there's a high pressure system over Alaska. So Alaska is actually experiencing unseasonably warm weather while we're getting unseasonably cold weather. And that's just an example of the kind of extreme weather events that are generally associated with climate change. There is even a little bit of a theory about that warm Arctic, cold continents. This is a publication that came out in Oceanography a few years ago, looking at this pattern and asking the question of whether we're going to see this more often with climate change. So I just kind of wanted to, climate in general is talking about long-term trends in weather, whereas weather is just what we experience day to day. In general, speaking of that long-term trend, this is just global average mean temperature. We can see from the 1880s to the present just that steady uptick in our global temperature. So warming still is that defining characteristic of climate change at that global level. And even more recently, this is just a figure from September of this year, where we can see here, we're seeing just this color scheme. This is a map of the surface of the Earth, and areas in red are warmer than average, and areas in blue are cooler than average. And you can see, even in September, just a few months ago, the predominance of warmer than average temperatures across the globe, and even many areas that are their record warmest in that time frame. So generally, we are still talking about a trend of warming. And with birds, we've already documented patterns. So this is a figure that came out a few years ago by a study done by the Audubon Society using data from the Christmas bird count. Who in the room has participated in a Christmas bird count before? Okay, so Christmas bird counts are a count that's done every year. It's a tradition that was started in 1900 as an alternative to the Christmas side hunt. So back then they used to go out and hunt, right around Christmas time, and someone had the idea that, hey, let's just go out and count birds and really enjoy this wildlife instead of always hunting. And that is a tradition that lives on today. So it's really the example of, one of the first examples of citizen science. And this is just looking at the period from the 60s to the mid-2000s. And what we're showing here are shifts in the distributions of species in that time period. So you can see dramatically, or overwhelmingly, a shift northward in some of these, from these dots. So kind of the light color to the dark color. So it generally shifts towards the north, and this correlates with an increase in our winter temperatures. And actually, one of my colleagues recently reanalyzed this data, moving all the way up to include the 2014 Christmas bird count. And now we're not looking at this as a map, but on the y-axis here, we're thinking about just the distance change. So the average distance moved north for species, and then this is over time. So you can kind of see, similar to the temperature, right? That steady uptick as species are spending their winters further and further north as the climate moderates during the winter months. And so it's in this context that a few years ago, Gary Langham, the chief scientist at Audubon, had this idea. Wouldn't it be fantastic if we could generate a field guide of the future? We all use our field guides when we go out into the field, especially beginning birders, right? You really need that field guide to think about, well, which species are even possible to be in this area. You use that field guide as a reference point, and it's filled with these maps that help you think about where species are in any given year. And so would it be great if we could generate distribution maps for the future, reflecting the impacts of climate change? And then, what if we could take that a step further? What if we could use those future maps to think about which species are more likely and less likely to be impacted by climate change? Some species might do just fine, and other species might be somewhat threatened or put at risk because of the changes coming with climate. And then one more step, what if we could use this information to inform our on-the-ground work? What if we could produce maps that we could use to help figure out where we should be focusing our energy from a conservation perspective to try to maximize our impact both today and into the future? Wouldn't that be a great, wouldn't that be worth the effort? And so that's what we've been doing, that's what we've done. That's what the Audubon Birds and Climate Report is all about. We've generated modeled future climatic suitability maps, so range maps for the future. We've identified which species have the possibility of being threatened by climate change. And then we've created what we're calling climate prioritizations, or maps, that help guide our thinking and focus our attention on certain areas that are going to be suitable for birds both today and into the future so that we can maximize our impact as a conservation organization. The backbone of this work is in our citizen science. So this, one of the major sources of information that we use in doing this work is the Christmas bird count. And again, that's collected by people just like you that every Christmas have gone out and surveyed birds ever since the beginning of the century. We combine that data set. So this is a map of Christmas bird count circles. So you can see we have really good coverage across the United States and much of Canada. This is certainly a unique source of information. There's not many sources of information this complete with this much geographic coverage. We combine that with the breeding bird survey, which has a similar level of geographic coverage, but it's a survey that's done during the breeding months in the summer. And that's a little bit different from the Christmas bird count. In the breeding bird survey, they're driving routes along roads and conducting point counts at regular intervals. So they're stopping for 5 minutes and writing down all the birds that they see and hear, and just doing that along the same routes every year. And this was also started in the 60s, so another long-term data set for the breeding season. We took this information on these observations of where we see birds and where we don't see them, and we combined it with information on climate, and we used something called bioclimatic variables. This is basically just taking information about temperature and precipitation and kind of translating it into these variables that are more meaningful to wildlife and birds. So thinking about things like how cold is it in the coldest month, or how wet is it in the wettest month. Just a little bit more refined way of thinking about climate. And so what we did is we took our bird observations and we combined it with historical climate, and we built a mathematical relationship that identified where each species is going, what climate it prefers, what climate is suitable for that species. And those relationships are called bioclimatic models. And we did this for 588 species, 475 species in the summer, and 503 in the winter. So lots of species. We then tried to think about the future. And it's tough, right? Because we don't know exactly what's going to happen in terms of climate change. And so the way we think about the future is using scenarios. And the IPCC, the Intergovernmental Panel on Climate Change, has developed different scenarios for how the atmosphere may change in the future. And they call those emission scenarios. So we used a low, medium, and high greenhouse gas emission scenario. So it basically kind of characterizes how much carbon dioxide and other greenhouse gases are emitted into the atmosphere. And those correspond to different amounts of warming. And so, the high emission scenario corresponds with more warming in the atmosphere. Kind of the purple here corresponds to the red here. This is global surface temperature over time. And these emission scenarios are then input into general circulation models, which are very sophisticated numerical models that simulate climate. They basically divide the atmosphere up into different strata, different kind of height strata, and then different latitudinal zones. And they simulate all the sophisticated atmospheric processes that characterize climate, including the greenhouse gas effect, which is the idea that as there's more greenhouse gases in the atmosphere, that traps warm air and warms the surface of the earth. So basically, we took our models that I mentioned earlier for all of our species, and we then took the output from these general circulation models run under these different emission scenarios. And that produces maps of future climate, and we input those into our models to create maps of future climatic suitability. Okay? So that's just a description of what we did and how we did it. Let's see what it looks like, okay? And so this is a map that you can find on our website. I'm hoping that many of you have visited the website, and if you haven't, I hope tonight when you go home you'll check it out. It's climate.audubon.org. And these are maps that are showing you projections of how species distributions may shift in response to climate change. And so this is it's an animated map. And I just want to take a few minutes to kind of explain what you're seeing here. And so we're animating through the present, 2000, and then 3 time periods in the future, the 2020s, 2050s, and 2080s. We're showing you where we expect to find the bird in the summer, which is in yellow, and the winter, which is in blue. We also have kind of solid lines on here. That's mapping out the core range of the species. So that's where you're most likely to see the species in each of those seasons. And then otherwise, the color, the darker the color, the more likely you're going to find the species in that location. And so what you can see is kind of how the species is shifting into the future. This is the hermit thrush. And so what you're seeing in the summer is a shift towards the north, as well as in the winter, again, kind of a shift towards the north. And in particular, the possibility that by the end of the century, we may not be seeing the hermit thrush breeding in the woods of northern Wisconsin like we see today. The climate is not going to be the same in northern Wisconsin as we're used to right now. And so let me return back to our list of tools here. What I've just described to you is how we've produced these climatic suitability maps. And don't worry, I'll be showing you more of these maps later. But I want to just jump to the second part to give you a sense of how we then use these maps. We tried to look across species and identify those species which were more likely to be kind of at risk due to some of these changes that we're forecasting for the future. So what we did is we kind of characterized species based on their projected response to climate change. And so you can kind of think about this, if this solid line is just where we expect to find the species today, where it exists today, and then the kind of peach color in each of these is where our projections are saying the species is going to be in the future. So we kind of have 3 different possibilities here. Here's one where the projection of the future encompasses where the species is today, as well as adds some new places, so it's kind of expanding its distribution. We're calling these species climate stable. Then we have species who their future projected distribution is, maybe it overlaps with their current distribution, but then it also goes into some new areas. So the question is whether species, we don't know whether species will be able to make those shifts into those new areas, and so we're calling those species climate threatened. And then finally, there are some projections where the future projected range is much smaller than where we see the species today, and so we're calling those species climate endangered. And there's kind of more formal definitions of these that I wanted to just mention. Climate stable, projected loss of less than 50% of their current range across all scenarios and time periods. So that's an important point to bring out. So these categories are based on all of our different emission scenarios, low, medium, and high, and looking across all time periods in the future, the 2020s, 2050s, and 2080s. The climate stable species include 274 species out of the 508 that we modeled. Climate threatened species are projected to lose more than 50% of their current range by 2080, again across all of our scenarios. That's 188 species. And our climate endangered species are projected to lose more than 50% of their current range by 2050, so sooner, again across all scenarios. And these are not projected to have any expansion elsewhere. And then if we add our threatened and endangered, these are the 314. If any of you get the Audubon magazine, that number 314 is kind of featured heavily on the cover, and is kind of a nice headline for saying that, you know, maybe half of the species that exist in North America are likely to be impacted by climate change. I think we were going to save questions to the end, but if you want to quickly ask me something, I'm happy to try to answer it.
What about species with conflicting results across different scenarios?
So the results so we looked for if they, only if they satisfied one of these criteria across all of the scenarios, did they fall into one of the categories. Yeah. So pretty conservative characterization. Okay, and so let's go back to some of those, or let's add some new species and start talking about some of the species that we know and love. This is, again, the hermit thrush. For me, this is a special species because I first identified it when I was camping up in northern Wisconsin, out with some friends, and I just woke up in the morning and heard that call over the lake, that ethereal, whistle-like call, almost like a flute. And I was just like, what is that? That's an amazing call, and something that I'll never forget. This is a species, as I mentioned earlier, that may no longer be found in the woods of northern Wisconsin if climate change progresses forward in the way that we're projecting today. Again, this is the map that I already showed you, so we've kind of already reviewed this, but the distribution kind of moving towards the north in both the summer and the winter. This is also the case for many of our wood warblers that are found in northern Wisconsin. They kind of follow a similar pattern, so I'm not going to show you maps for all of them, but ovenbird, black and white warbler, chestnut-sided warbler, American redstart, and help me out, I'm forgetting. One of these is Nashville warbler, I think this one. This one? And then what's this? Sounds like there's a little bit of disagreement. But this group of wood warblers that are common in breeding season in northern Wisconsin are all projected to shift north. This is a little bit of a different perspective. The boreal chickadee is a species that is fun to find during the winter months, right? It's usually found up in northern Wisconsin. I remember a field trip that we took during ornithology when we spent many hours looking for a boreal chickadee and just never found one. I saw lots of black-capped chickadees, but no boreal chickadees up there. And it's a species that is projected to, Now we're kind of focusing in on the winter months as being sort of relative to Wisconsin, but not really likely to find this species in the future coming this far south. Okay, so maybe on a different, kind of thinking about it in a different way, not the breeding season, but the non-breeding season. Similar story for Bohemian waxwing. This is a species that in the future It's listed as climate endangered because of the projected contraction in its breeding range, so the breeding distribution is projected to contract, but from the perspective of Wisconsin, we're seeing, again, it leaving the northern forests by the end of the century. Shifting habitat types to the bobolink, this is another climate-threatened species. This species isn't found in the United States during the winter months, but during the summer months, we're predicting that this species is going to be shifting into regions that are currently kind of a boreal forest. And so the question here is, these are happening within the next 100 years. What is it going to look like up there in the next 100 years? Are there going to be grassland habitats that are required by these species, or will they be kind of squeezed on the north by habitat and on the south by warmer temperatures? These are the things that we're concerned about. The mallard duck. This is a species who is climate endangered, again, because of its breeding distribution, because we're seeing a potential shift in its breeding distribution towards the north. At least the climates that are suitable for the mallard, where we find them today, are going to be shifting further north. And so, what is the potential impact on this species of that shift? And then finally, kind of a different story. This is the lark sparrow. This is not super common in Wisconsin today, but its projections are that it might become more common in the future as it moves into, as Wisconsin potentially becomes warmer and drier. So let's return kind of to this framework that I presented. We've talked about our field guide to the future. We've talked about our climate sensitivities and being able to identify which species are more or less likely to be impacted by climate change. Let's now think about how we can translate this information into on-the-ground work. What can we do with this? And what we're calling here are our climate prioritizations. And so the thing about climate change is we can make these projections, but we don't have a lot of certainty. I talked about different time periods. I talked about different emission scenarios. We don't really know which emission scenario is going to happen. There's a lot of uncertainty. So we don't know how much greenhouse gases people are going to be emitting into the atmosphere. We don't know exactly how the climate is going to respond to those emissions. And then the other factor is we don't actually know how birds are going to respond. We don't know if they're going to track climate. We don't know if they're going to say, I don't care. I'm just going to stay where I am. There's different ways that birds can actually respond to climate, so we need to incorporate that into our planning. So what I'm going to walk you through are some spatial prioritizations. These are different from our maps of climatic suitability. What a prioritization is a map that ranks the conservation value of different climates across your landscape for one or more species. These are incorporating multiple climate scenarios, multiple future time periods, and multiple hypotheses about how birds might respond. So let's think about how birds might respond to climate change. You can imagine a species that isn't very tolerant of new climates. You know, they really like where they are now, the type of climate they're in now. And they might not be very mobile. They might not have the capacity to move. And so these species are going to kind of suffer in place. They're just going to hunker down where they are and make the best of the conditions that they get. We can also imagine another species that, in a similar way, you know, they really like where the kind of climate that they're found in today. So they're not tolerant of new climates, but maybe they're more mobile. And you think of a lot of birds as being pretty mobile, right? And so they're going to probably be able to track and move with climate change and follow the climates that they prefer. And then we can think of kind of a third group of species as being species, maybe they are found more around human habitations, or maybe they just simply aren't very sensitive to climate variables, different climate conditions, and they're just going to stay where they are because that's where they are now, and they're just going to stay where they are. So we can kind of think about all these different ways that birds can respond to climate change. And so what we did was we took our climate suitability maps for the present, and we combined it with all our maps of the future under these different emission scenarios and these different time periods. Then we consider these three different biological responses. You know, are they going to track climate change? Are they going to just stay where they are and suffer with new conditions? Or do they really not care about climate change? And we built different prioritizations, and then we kind of combined them and took the best of all and created one prioritization for each species. And so this is what a prioritization looks like. I just kind of want to walk you through it. The dark colored here corresponds to areas that have the highest ranking. So high ranking areas are going to have, they're going to be suitable for a species both today and into the future, these dark green areas. Low ranking areas or light colored areas are not really suitable for the species both today and into the future. And then the gray area is just not really suitable at all at any point in time. We've also included on these maps an outline of the core climatic suitability today, so you can kind of see where the species is found today. And then also, some of the things that we can deduce from these maps is if we see a dark colored area that's outside of the core climatic suitability, we can see that that's an area where we're going to see future expansion, where the species is going to move to in the future. And then similarly, if we have a light colored area within this outline, that's an area that is likely going to represent contraction, so where the species is probably going to leave in the future. So we can get a lot out of these maps. And these are useful for identifying what Audubon is calling climate strongholds. These are areas that are valuable for a species, one or more species, accounting for the potential impacts of climate change. And these are useful because we can use them to guide our conservation efforts. So we can identify the most important places in the state of Wisconsin or across the entire Mississippi Flyway for conserving birds for climate change. The areas that have the highest ranking. And so what we're working on right now with states and flyways is kind of identifying places on the landscape that are the most important, that are going to be suitable for species both today and in the future. So just to show you a few of these maps for the same species that we talked about earlier. So here again, we get some dark colors in northern Wisconsin for the hermit thrush, okay? But on this national scale, we can kind of see that Wisconsin is a little bit light in green. It's a little bit lighter color, and that reflects the fact that we're expecting the species to be moving north and out of the state in the future. The boreal chickadee, remember we talked earlier about how we really just see it in the winter and just at the northernmost part of Wisconsin. Well, in the future, and if we look about this in terms of trying to find the most important places for boreal chickadee, the color here is a very light yellow, and so really the darkest areas across this distribution are much further north. Okay, so Wisconsin has very low importance in terms of the impacts of climate change and thinking about the boreal chickadee in this area. So that might be an example of a species that we, in Wisconsin, might not want to focus a lot of energy on because it's likely to be moving north and out of the state in the winter. Bohemian waxwing is similar again. We're kind of on that southern extreme of its distribution, and so its importance, Wisconsin's importance, is not very high. The maximum value here is only 0.8 out of 1. But we can still identify some areas in the UP and in northern Wisconsin that are a little bit relatively more important than other areas. Bobolink still comes up as being important in Wisconsin, a little bit maybe north of where you would expect, kind of in the central part of the state, as potentially having climates that are suitable for bobolink both today and in the future. Mallard, similarly, still has areas that are pretty important for mallard that consistently over the next century, you're getting some dark areas, and certainly in Minnesota, areas that are going to be suitable over the course of the century. And then finally, this was my example of a species that might be moving into the state. Again, we're seeing that we're really just in Wisconsin, we're kind of on the fringe of this species' projected distribution, and so the rankings in the state are really low. This is not necessarily some really important strongholds for this species, but it is possible that the species may be moving into the state in the future. And so, kind of in conclusion, this is what we've done in the Audubon Climate Report. Is we've created this field guide for the future, maps of where we expect to see species in the future with response to climate change. We then looked across species and picked out which ones are more and less likely to be threatened by these changes. And then we've created these prioritizations, which are useful tools for looking across the landscape and identifying places that are going to be suitable for these species both today and the future, and we can use these to guide our conservation efforts as a conservation organization. So what can you do? this is a map of important bird areas. This is a great program that Audubon has had for many years, trying to identify places across the United States that are really important for birds. And these areas are still going to be important in the future. What you can do is to contribute to this effort, to work on restoration projects, to support your bird areas, get them attention, visit them, improve their habitat quality, get people talking about how to preserve their water rights in the future. Focusing our efforts on strengthening populations today will only improve their chances of dealing with the changes associated with climate change in the future. There's also a lot of opportunities for leadership and to get involved. We need leaders that are going to be stewards for both our IBAs, our important bird areas, and our new climate strongholds, these areas that are going to be suitable both today and into the future. We need leaders that are going to be, willing to draw attention and focus their efforts on improving habitats in these important areas across our state.
Where is that?
That's just a generic photo. I'm not actually sure where that is. That looks like a big city somewhere. There's also an opportunity to support policies that are trying to reduce our emission of greenhouse gases. Just to express your support for those policies, to bring this climate science to the attention of your local governments. I know that some chapters, Audubon chapters, have taken this climate study and asked their city to incorporate birds into their planning for their city development plans. And there's lots of opportunities to bring the message of, hey, we love birds and they might be impacted by climate change, let's pay attention to this. There's lots of opportunities to share that message with decision makers. And then finally, at Audubon, this is something that we have launched a large campaign, a climate initiative around this topic. We are going to be continuing to update our science and improving upon what we've done. Actually, one of the great one of the impacts of this big launch and all the media blitz is we're getting lots of phone calls from people who want to partner with us and work to make our science even better in the future, and that will only prove to allow us to do better for birds and conservation of birds under climate change. We're also going to be launching a new citizen science project called Climate Watch, where we're going to be looking at some of these projections and seeing if they're true. Maybe they're all false. We need some data, we need some information to test whether these projections are coming true, and that will only allow us to make better conclusions about the impacts of climate change in the future. One of the things that David Yarnold, the CEO of Audubon, likes to do is to put this in perspective. The Audubon Society was formed around the turn of the century, and one of the biggest issues that they worked on was trying to get restrictions on harvesting of birds for the millinery trade, for making women's hats with bird plumes. And they were successful in reducing the amount of harvest of those birds and protecting those birds. Another large-scale initiative that Audubon played a role in was related to Rachel Carson and Silent Spring. In 2013 was the 50th anniversary of the publishing of Silent Spring. Audubon played a huge role in documenting the impacts of DDT on bird populations. And so this initiative, this climate initiative, is something that Audubon sees as another kind of major initiative within our organization. It's a major topic that we want to be on the forefront of in the future. And so in conclusion, I'd just like to invite you all to visit our website, climate.audubon.org, where you can find information on the impact of climate change on birds. You can find more of these maps. You can look up your favorite species and see how it might be impacted by climate change. What are the species that are threatened and endangered across the United States and Canada. So thank you very much for your attention, and I'd be happy to take some questions.